Hello everyone. Hopefully everyone made it through this homework without too much difficulty. So jumping right in, we have some instructions to keep the files in the .gz format, to not load them into BigQuery, to just load them into a GCP bucket, and then create an external table and a regular BigQuery table. And we have a link to the data files here. We see the 2019 files, and over here I have a bucket with the files already loaded, and we could go to configuration and just grab that URI, and over in BigQuery the first thing we would want to do would be to create a data set. In my case, I created one and just called it HW for homework, but you could call it whatever you'd like. And then create the external table and create a replace external table, the project ID, the data set, and then what you'd like your table to be called. In my case, I just called it FHV external table. And then the options, you would just use CSV for the format, and then the URI for the GCP bucket, and star.gz just saying which files we would like to use. Since they're the only files in there, you probably could have gotten away with just using star. And then to create the regular table, again, create a replace table. You could also create table. This will yell at me because I already have one, but create or replace takes care of that. Again, the project ID, the data set, and what you would like this table to be called. And then as and where you're getting the data from, which in this case would be the FHV external table. This does take 3 or 4 minutes to run, at least it did for me, so I already have that loaded. So that's it for the setup. Now on to the questions. Question 1 is, what is the count for FHV vehicle records in 2019? So we would just need to run a count query, and you could do that on the external or the regular table. It would probably run a little bit quicker on the regular table since the data is already here. And we get 43,244,696. So that would be the answer for question 1. Question 2 asks you to write a query to count the distinct number of affiliated base number on the entire data set, and then use the external table and the regular table and see what the estimated bytes processed will be. So that would just be a count for the distinct affiliated base number, and do the external table. We see that it is 0 bytes here. Because the data is not actually in BigQuery, it cannot estimate how many bytes it is going to process. If we switch that to the regular table, we get 317. So for question 2, we were looking for 0 megs estimated for the external table and 317 for the BigQuery table. Question 3 asks, how many records have both a blank pickup location ID and drop-off location ID? So again, you could have done this on the external table or the regular table. Probably going to get better performance on the regular table. And when you run that, 717,748. So that would be the answer for question 3. So question 4, what is the best strategy to optimize the table if the query always filter by pickup date time and is ordered by affiliated base number? Well, the filter word should give you a hint here that we would want to partition on that. You can only partition on integers and date-like values. if you do a quick Google on that, you see over here on the right what are the types you can use for partitioning. And then if we are going to order by the affiliated base number, clustering is what's going to give us that ordering. And affiliated base number, if you peek into that table, you can see it's a string data type, which is not listed, so you can't partition on it. So the answer we're looking for on question 4 would be to partition by the pickup date time and cluster by the affiliated base number. Question 5 asks you to implement the solution from question 4 by creating that partition table, and then write a query to get the distinct affiliated base number between 3/1/2019 and 3/31/2019, and then to notice how many bytes are estimated to be processed. So to create the partition table, we would create a table, same as before, give it a new name, tell it what we would like to partition by. In this case, we cast the pickup date time to a date and cluster by the affiliated base number. And then the data source, which could have been either the external table, I believe, or the regular table. So once you run that, you would go ahead and select the distinct affiliated base number from either table. Just make note of the bytes processed up here. And I used between, but you could have done greater than equal to, put pickup date time again, less than or equal to 3/31, and it should be the same result. So the regular table is estimating 647 megs will be processed, and if we switch to the partition table, it's estimating 23 megs. So when we look here, 64.7 megs on the non-partition and 23 megs for the partition table. Question 6, where is the data stored in the external table you created? Well, we saw it couldn't estimate the bytes that will be processed, so the data is not in BigQuery. Container registry has to do with Docker containers. Bigtable has to do with NoSQL, and it's not touched on in this course. So process of elimination, and we provided the URI when we created the external table. So the answer is GCP bucket in this case. Question 7, it is best practice in BigQuery to always cluster your data. As Ankush stated in the video, if your data is less than 1 gig, that will create some metadata that has some overhead associated with it, which may outweigh any performance boost you'll get from clustering. So the answer to 7 would be false. And then question 8 just gives you some ideas on how to expand on what we did in this homework if you're interested, and convert the CSV files to Parquet. Probably need to do some data cleaning there, and that's just there if you'd like. But I hope everyone did well on the homework and didn't get hung up on these questions too much. And that is it for this week.